Okay, let's examine those two methods for solving the system of equations once again. And I'll demonstrate that the two are exactly the same. So let's take the same equations that we took in the class. So we had y equals 3x minus 2, and we had x minus y equals 2. And what we did was we said, well, rewrite these equations so that you have x equals something for both or y equals something for both. And in this case, it's easier to do the y equals something. And so that's what we'll do out here. And I'm going to label this as 1, and I'm going to label this as 2. And so we rewrite equation 2 as x minus 2 equals y. So I subtracted y from both sides, I subtracted 2 from both sides, and that's what I got. And so now we have y equals something out here and y equals something out there, and we are looking for the y's to be exactly the same, right? We are saying we want a common solution for the two equations, and therefore the y for both must be equal. So what are the values of x for when the y's are the same? 3x minus 2 and x minus 2. And so these must be equal as well. So that therefore we can say 3x minus 2 equals x minus 2. And now I solve for x. And so I get, this gives me 3x minus x equals minus 2 plus 2. What I did here was I subtracted x from both sides of the equal to sign, and I added 2 to both sides of the equal to sign. And so I get 2x equals 0, and this gives me x equals 0, right? So now we take this value of x equals 0, substitute it in one of the equations. So let's pick equation 2 just because it's easier to do. And I will write this as 0 because that's my value of x minus y equals 2. And so this gives me minus y equals 2, and this gives me, therefore, y equals negative 2. Now, so this is my solution, right? X equals 0, y equals negative 2. This is my solution. And I can verify this by substituting these values in equation 1 just to confirm that, hey, what I did is okay. So let's take y equals 3x minus 2, and that's going to give me, let's put a verification out here. So negative 2, that's my value of y, equals 3 times my value of x is 0 minus 2. And I get negative 2 equals negative 2, and that's confirmation that my calculations were correct. Okay, now let's solve using the other method. And what I'm going to do is insert this dividing line between my calculations. And we shall now use the method where we are subtracting the one equation from the other. And I'm going to rewrite the first one, which is y equals 3x minus 2 as 3x minus y equals 2. And how did I get that? Well, I subtract y from both sides here. I subtract 2 from both sides, or I add 2 to both sides here, and that's how I get 3x minus y equals 2. And then I'm writing x minus y equals 2 below it. So x minus y equals 2 just below that. And remember, the first method, what would we do? We said, okay, write y equals something on both sides, so get rid of the y. And so we're going to do exactly the same here. We'll say, I want to get rid of this y, so I'm going to subtract the second equation, x minus y equals 2, from the first one, 3x minus y equals 2. Why does that work? Suppose I have two random numbers. So let's say, I'm just going to write it here. Let's say I have 12 equals 12. Okay? And do I know the value of x minus y out here? Yeah, I actually do. It's 2. Suppose I subtract 2 from both sides of this, right? I shouldn't have put the equal to out there. Let me just fix this. Whoa, that was not what I intended doing. Let's try to keep it. Okay, this is a little bit of a blunt instrument here, the eraser. So let's go back to the pen, and I say 12 equals 12, and I'm going to subtract 2 from both sides. And what do I get? 10 and 10, right, when I do this calculation. So we can see, yes, the equality is preserved between the two, and it's okay to do. So given that we have, oh gosh, I'm going to have to clean this up here. We had 3x minus y equals 2 out there. So let me fix that. And we have x minus y equals 2 out here. Okay, that's what we had started off with. So I'm going to subtract this second one from the first one. So I'm going to flip the signs here because that's what will happen when I'm subtracting it. And so the minus y plus y goes away because it gets 0. 3x minus x gives me 2x, and 2 minus 2 gives me 0. And so this gives me x equals 0. And guess what? We are exactly at the same point that we were here in the first calculation. Now I can take x equals 0. I'll substitute it in equation 2 or equation 1. I'll find the value of y. I've got both x and y. I can plug them in like how I did the previous time to verify that they're correct, but the steps that follow are exactly the same. But pay attention to this. I got 2x equals 0 out here, which is exactly the same as this step. So got exactly the same as this step. And what is the step prior to that? 3x minus x equals negative 2 plus 2. That's exactly the same as this one. Okay, that's exactly the same as this one where we are doing 3x minus x and 2 minus 2. Okay, so both methods are doing exactly the same thing. We are getting rid of one of the variables, one of the unknowns. In this case, we did y. So in the first method, we said we'll rewrite both equations so that they are y equals something, and then we'll equate the other two sides. So we had 3x minus 2 equals x minus 2. And here we did exactly the same thing by subtracting the equation one from the other so that we could get rid of the y, and we were left with the x's. So both methods are the same. You need to understand what we are doing, then you can always solve them. Thank you.